Section 8.3 is on graphing reciprocal functions. The parent graph of the reciprocal function is f of x equals a over x minus h plus k, where the numerator is a constant, so it's going to be just a plain number, and the denominator is a linear function. It's going to have just an x, not an x squared or an x cubed. And then there's a k added on the end. This function has a vertical asymptote at the line x equals h, so whatever h is, that's going to be a vertical asymptote, and it has a horizontal asymptote with the line at the line y equals k. So whatever k is, y equals k is going to be your horizontal asymptote. So let's take a look at a couple examples here, and here are some pictures from the text. We need to identify the asymptotes and the domain and range of each function. So here we have f of x equals 4 over x minus 1. So for this graph, my h is 1 and my k is 0. It's a little confusing. It says x minus 1 on the bottom, but remember the form is x minus h. So h is 1 and k is 0. Actually move that down. So that means that I'm going to have a vertical asymptote at the line x equals 1 and a horizontal asymptote at the line y equals 0. And let's take a look at that on the graph. I'll just go ahead and write over this. So this is where my vertical asymptote would be. That's the line x equals 1. And I have a horizontal asymptote right here, which, yes, it is the x-axis, but it is also the line y equals 0. So those are my two asymptotes. Now, when we go to write our domain and range, as you can tell from the graph, x can be anything except 1. So my domain is the set of all x such that x is not equal to 1. And my range is the set of all y such that y cannot be 0, such that y is not equal to 0. So that's my domain and range. Here's another example. Here's the function 3 over x plus 2 and then plus 1. So let's identify our h and k. So h is equal to a negative 2, and I know it looks like it's positive 2, but it's actually x minus h, so that would be x minus a negative 2. So that means I have a vertical asymptote at the line x equals negative 2. And let's just go ahead and draw that. Here's the line x equals negative 2. That's my vertical asymptote. And then my k value is 1. So that means I have a horizontal asymptote at y equals 1. And let's go ahead and find that line. Here's the line y equals 1. And I don't think I said it earlier, but just a reminder. An asymptote is a line that the curve approaches, but it will never touch. It just gets very close to that line, but it will never touch that line. So for this function, my domain is the set of all x such that x is not equal to negative 2, because looking at the graph, the curve approaches, this way, curve approaches negative 2, but it never gets there. And the range, the set of all y such that y is not equal to 1. Okay? Now, let's try graphing a few of these, and we're going to state the domain and range. So my first one is f of x equals 2 over x. To do that, I'm going to start on my graphing calculator. So I'm going to put in 2 divided by x and take a look at what that graph looks like. Okay, so I have a curve right here, okay, and right there, all right? And then actually looking at what I have written here, I have nothing added or subtracted to or from x in the denominator, so my h is going to be 0, which means that I have a vertical asymptote at x equals 0, okay? And that's actually going to be the line, actually that's the y-axis. Okay, that's the line x equals 0. And since I don't have anything added on the end, my k is equal to 0, so I'm going to have a horizontal asymptote at y equals 0. And that's the horizontal line, which is basically the x-axis. There's the line y equals 0. Which makes sense now when I go back and I look at my calculator to see the values that I have. I can indeed see that the y-axis is a vertical asymptote and the x-axis is a horizontal asymptote. Let's go to our table to get some values. So I think I will start with, I'm going to start with negative 4 and negative 3. I don't like negative 3. I don't like that value. That's actually negative 2/3. Let's use negative 2 instead. That's better. Negative 1, 0. Exactly. Doesn't it make sense? X cannot equal 0 because that's one of my asymptotes, so I get an error message. And let's use 1 and 2, and let's use a positive 4. So that gives me some nice values to put in my table. So let's copy that over here. So I have my X and I have my Y. I'll do it this way since I have a lot of values here. So negative 4 gave me a negative 1/2. Negative 2 gave me negative 1. Negative 1 gave me a negative 2. And I saw when I put a 0 in I didn't get anything, as I should. And then positive 1 gave me 2. Positive 2 gave me a 1. And 4 gave me 1/2. So let's graph those points. So I have negative 4, negative 1/2, negative 2, negative 1, and negative 1, negative 2. And remember, the graph is asymptotic. It approaches the asymptotes, so it needs to look like that. Do not cross those lines. And undefined at 0. Then I have the point 1, 2, point 2, 1, and 4, 1/2. And it's going to look like that. So when you're graphing these, I want to see, whoops, that's not real straight. I want to see the curve, I want to see it approach the asymptotes, and I want to see it approach the asymptotes. Now, to identify the domain and range, domain is the set of all x, such that x is not equal to 0, and the range is the set of all y, such that y is not equal to 0, because those were my values for my horizontal and vertical asymptotes. Okay. Let's try another one here. F of x equals negative 4 over x plus 2. So let's identify h and k and find our asymptotes. So h is equal to a negative 2, so that means I'm going to have a vertical asymptote at x equals negative 2. And k is equal to 0 since there's nothing added on the end. So I'm going to have a horizontal asymptote at the line y equals 0. And even before I go to my calculator, I can graph these. So here's the line x equals negative 2. And here's the line y equals 0. Okay. And let's go to the calculator and graph these. So let me clear that out. And we have negative 4 divided by, now put your denominator in parentheses since this was x plus 2. I'm going to parentheticate that. Whoops. Forgot my 2. Okay. And let's graph. And that makes sense. Can you actually see here where there would be that vertical asymptote of the line x equals 2? Okay. Let's pick some numbers here. And actually, I've kind of looked at this in advance. Some numbers for our table. Let's try negative 10. It's going to give me a 1/2. Let's try negative 6, negative 4, negative 3, negative 2. Oh, I got an error message, and that absolutely makes sense because x cannot be negative 2, because when x is negative 2, my denominator is undefined. And what were some other values that I had here? If I go with a negative 1.5, I'll get a negative 8. Negative 1 gives me negative 4. 0 gives me a -2, and then if I were to put in a 2, I would get a -1. Let's go ahead and copy those in a table over here. And remember, when you're plugging in values into your table, you may not know what to do. Just look at the graph, start far enough to the left, and if you start to get some really weird fractions, just don't worry about them. Keep going until you find some numbers that you like. And here are some numbers I like. -4, 2, -3, 4, and remember -2 didn't work. That's good. And then I had a -1.5, which gave me a -8. -1 gave me a -4, 0, -2, and 2, a -1. I think that's enough points that I can go ahead and graph this. So, -10 and 1/2, so that would be right about there. -6, 2, 4, 6, and a +1. 4 and a +2. 3 and a +4. And I can't do -2 because that's my line, my asymptote. So here's part of the curve right here. Notice also that these curves are going to have 2 parts to them. And then a -1.5 is right here, and that's going to be at -8. -1, -4. 0, -2. And 2, -1. Okay. And there we go. My domain and range. My domain is going to be the set of all x, such that x is not equal to -2. And my range, the set of all y, such that y is not equal to 0. So, in order to graph a reciprocal function, easiest way to do this is to identify your h and k, which we can get from the parent function here. Okay. Identify your vertical and horizontal asymptotes, graph it on your calculator, and identify the domain and range.